Hi students, I'm your geography teacher. So, in this video, we are going to discuss the continental drift theory and plate tectonic theory. And in the last part, we are going to discuss the theory of isostasy. Okay. So, in this video, again, in this part, we are going to discuss only the continental drift theory. Okay, let's start the session. First thing, if you want to discuss that the one of the scientists, perhaps you know his name, that is the Alfred Wegener. Actually, basically, he was the German climatologist. Okay, and first he proposed the one theory, that is the continental drift theory. Actually, this theory too much developed, or some criticism are there, but that was the first attempt to explain given the explanation about the formation of the earth, formation of the continents, formation of the mountain and the ocean, okay, and all the seas. So that's why this theory is very, very important. Okay, so this scientist started this theory, and that theory was published in 1912. Okay, and let's start this theory. What is the before starting this continental drift theory, perhaps you know, in the later part, in the plate tectonic theory, we also broadly discussion will be there regarding the plates. Okay, plates or the lithospheric plates. Somehow you know that our earth's surface is combined with 20, you can say, the minor plate and 6 major plate. Okay, so 6 major plates. What are the 6 major plate? North American plate, South American plate, African plate, Eurasian plate, okay, Australian plate, Pacific Ocean, Pacific plate, then come to Antarctican plate. So these are more or 6 and 7 major plate on the astronosphere, on our Earth surface, and there are 20 minor plates, that is the Japan plate, Nazca plate. Okay, so these are the plates. Always these plates are floating, you can see now, on the astronosphere, or that is also known as the upper mantle. In interior part of the earth, we already discussed that the interior structure of the earth, that is that there we discussed the crust, mantle, and the, you can see, the core. So these plates or lithosphere plates always floating on the, you can say, the where, on the astronosphere, and the floating rate is very, very low. That can be, you can say, the 2 to 5 centimeter per annum, or a few millimeters. So according to this Alfred Wegener, actually Alfred Wegener wanted to say that these continents have joined together once upon a time. It may be millions of years ago. So that time, whenever this all continent, means the North America, South America, Africa, Asia, Australia and Antarctica, they are together. Okay, so that's why that time it is known as a Pangea. Okay, this supercontinent that time is known as a Pangea, and outer surface or outer part of this Pangea, that was the one ocean. So one super ocean, you can say, that time it is known as the Panthalassa. So once this process started, and slowly this supercontinent started to break down, or started to crack, and some portion, you can say, the North and South America goes to the westward, Australia to the western side, and you can see the India towards the northeastern side, okay, or the northern side, and Antarctica to the southern portion. So due to this fact, in between North and South America and Africa, there is an ocean, that is the Atlantic Ocean, and in case the rest of the ocean, Pacific Ocean, and India and Antarctica between the Indian Ocean. So in this way, our continent was formed. According to this person, Wegener, Alfred Wegener, so Pangea and Panthalassa, and he also described northern portion of Pangea. Okay, northern portion of Pangea, that time it is known as the Gondwana. Okay, and the northern portion Laurasia, and southern portion is Gondwana land. Okay, so northern portion is Laurasia, perhaps you know, that is the North America, Europe and Asia. So that time it is known as the this is Laurasia, and southern portion Africa, India and South America, that time it is known as a Gondwana. Okay, in between there is a sea, the sea name was a Tethys Sea. According to him, he described a lot about this in his theory. Okay, so these are the main two things you have to memorize. But to establish this theory, to establish this, you can say the hypothesis, he has given, or he already submitted some evidences, because you are going to submit a theory. So that time some evidence, whatever you are telling, that evidence you have to submit before the conference. So, and in your book with the evidence. So some evidence he has already described of the apparently movement of the physical features, that is botanical evidences, placer deposit, okay, then the tillite deposit, polar wandering, distribution of the fossils and rock of the same age across the ocean. So these are the evidences. So one by one we have to discuss this thing, or these evidences, how the wanted to prove that he, whatever he is saying, that is the full right. Okay, totally right. So here you can say the first theory or the first evidence he has given, the polar wandering. Okay, so perhaps you know we have a two, you can say the more or less two, you can say the pole. One is magnetic pole and another geographical pole. Geographical pole, north and south, perhaps you know, north pole and south pole. And another is the magnetic pole, means the one which the magnetic pole is, you can say the magnetic, you can say the our earth interior of the part, there is a continuously magnetism, or the magnetic or magnetism, or you can say the wandering also. So that's why this magnetic pole are, you can say the moving from time to time, or from the geological time scale. So polar wandering is a migration of the magnetic pole. Polar wandering, what is the you can say the migration of the magnetic pole over the earth's surface through the geological time, and position of the geomagnetic pole, north pole, and map, you can say the northern pole, making known as the times of the geomagnetic pole, that north pole since 19. Okay, so these are the, so these magnetic pole are shifting slowly, these are shifting, and scientists has got number of evidence regarding this. So these are the one, you can say the, if there is a polar wandering is going on, so that time our continent can also be shifted. So that's the evidence he has first given. Second thing, that the rocks of the same age across the ocean. So if you can see, there is a North America and South America, Asia and Africa. In between there is a North Atlantic and South Atlantic. If already the scientists or the geologists, or you can see the who study the rock or age of the rock, they already studies the eastern rock age of the eastern side of North America and western portion of Europe, their age is same. And you can see the eastern side of South America and western side of Africa rock are same, or they are the same level, or the same, you can say the same age. So by this we can easily understand, once upon a time, or you can see the geological time scale, that was the bind up, means that these were the in a one place. So somehow they are separated from each other. Okay, so these are the main things. The same rocks can be found across the ocean. So ocean means here they want to say the Atlantic Ocean. Next evidence is the geological evidence, that is the jigsaw puzzle. You know, nowadays you can, perhaps you know that the modern technology has been developed, and by the using this computer, or by this using the modern you can see the software, if we try to gather, so you can say that this thing means the North America to the Europe and South America to Africa. So that time there is a jigsaw puzzle, means that can mix up each other. So that can create a solve that problem, solve that the once upon a time, that was this all the continents, Asia, Europe, then come to the North America, South America and Africa, once upon a time, one place, in a one place. That's why he mentioned in his book, in his theory, Wegener, that is only one thing, that is the Pangea. He described as a Pangea. So this is the jigsaw puzzle evidence he has already given. Second thing, the fossil evidences. Okay, so some of the fossils means in the Triassic report, you can see that we already studied the geological time scale. So there we already studied that the some of the fossils remains in the Triassic land in the reptile, and some of the fossil evidence Triassic, that is the Latrostrus, and some of the fossils of the Glossoplateus. So these are the fossils of the Mesosaurus. These are the fossils can be found in the all over the continent. So it is impossible to go these fossils to the one area to another area, because now this time the situation, there is a big ocean between these North and South America and Africa. So that's why it is very, you can see the chance that once upon a time this area was together, means Africa, South America, Antarctica, and India and Australia, they were together. So somehow they are separated, and these fossils or their dead bodies, or you can say the fossils, also separated from or the found in the different continents. So these are the main thing we have to discuss. Second, third, you can see the pleasure deposit. Pleasure deposit, perhaps you know, that's the, you can see the deposit of the glacier deposit. Means the, if you one glacier come from up to downward, so that time some glacial material can also found over there. Okay, so this pleasure deposit can be found over the, you can see the different parts of the continent. Africa it is found, America it is found, North America, Greenland. So everywhere it is found, this pleasure deposit, and the same age. The pleasure deposit is the same age, or Europe it is also in found. So it is very chance that the once upon a time, this due to the pleasure, this continent were in a you can see the in a position or in a packed up manner, that is known as the Pangea. Okay. Another, that is the climate change. He has also given the climate change. Some of the climate already changed in the different part of you can see the world, and they got the evidences regarding there is an ancient pole, okay, that the climate was the same to the tropical. Okay, somehow you know the, you can say the Indian climate, somehow that is the tropical climate, or you can say that. So that's why we can get that this India was bound up near that equatorial area. Okay, somehow you know the Antarctica, there you can see the deposition of the coal. So deposition of the coal, how it is possible? Because of this coal deposition in the, because of this, the location of the Antarctica may be or might be in the tropical area or subtropical area or the equatorial area. So from there, the large vegetation over there during time of the shipment of the southern side of this Antarctica, and that time this you can say the this all plants or vegetation converted into coal. Okay, so these are the main evidences you can say that he has given. Next, another evidence is example of the changing climates. Already they have got the proof, somehow you can say tropical belts, and you can see the Mexico, there is a one climate also found. Then the you can see the Seattle, USA. So these are the climate. So some of the animals that can only survive in the you can see the tropical area, but now this time their fossils is found in the temperate or the you can see the polar area. So a little bit doubt can become your mind that once upon a time this area was in some places of the tropic or subtropic or equatorial area. So this we have to understand. But the Wegener problems, actually Wegener for cracking this or for shipment of this, for drifting of the continent, he has given some evidence on the forces. Actually there that time this lithosphere was on the Pangea, that the supercontinent, but how this supercontinent break down? But he gave the very lame, you can see the evidences. He told the gravitational force of the moon and sun is responsible for cracking in the Pangea. But that is the lame excuses, or you can see the lame evidence. Scientists was about the scientists were not agreed or did not agree about whatever this person or the you can say the Wegener said. Okay, so these are the forces he applied. So these are the drawbacks of the criticism. He could not find the forces that were causing the continent to drift. Because of this, he could not convince anyone that the continents could move. And he died on the Greenland, and an expedition at the time of the death. No one believed his hypothesis, but his hypothesis was null and void. Also, no one could not believe. Okay, that was the hypothesis, because he has given the one of the best example evidence he was given. But cracking of the drifting of the you can see the continent, that was also he has given. But what was the force? What was the force that cracking the continents? tracking the supercontinent or Pangea, drifting the continent. So he was somehow he given the force of the moon and earth, gravitational force of the moon and earth, but that was not believed the scientists that time. Okay, so thank you for watching this video.